Waves. How's it going? So this is March 2020 and we do have a serious problem in the world, that is coronavirus. It has been declared pandemic. People are scared. We are working from home and I think 10,000 people have lost their lives and there are many active cases. I hope everything goes well and every person should get healed, healthy. I wish to God that please, uh, I hope that this virus goes away as soon as possible. Okay. Uh, on the coding note, we today will be doing an algorithm which is actually uh, a greater element of the element in an array, the next greater element of the element in an array. So today we are going to find the next greater element of the traversing element which we are currently on. So here in array, suppose let's say I have 5. So for the 5, we have the next greatest element is 10. Now for 3, we have again 10. For 2, we have again 10. For 10, we have 12. So everything is listed here. You can see for 10, we have 12, 6, 8, 8, 12, 1, 4, 4, 12. And for 12, 7, 4, we don't have any because after 12 on the right, we don't have any element which is greater than 12. And we don't have any element for 7 and 4 as well, which are greater on their right side. Okay, so this is the crux which we are going to build using Swift. So the algorithm which we will be using is this with two simple steps, and I will be using the stack in this case. So how it will be going? So let's dry run this algorithm for at least for a single time. Let's see whether it works or not. So it says that push the element in stack if the stack is empty and the element is less than or equal to the top element of the stack. Okay, and the second point, the second step, it says that if the element is greater, then pop the elements of the stack till the element is less than or equal to the top element. So basically I'm coming to this statement again after, if I'm getting the opposite of this in the second. So let's run this, let's dry run this. So this is the element. Okay, and let's write the output as well after the dry run. Okay, so what the output will be, for the first time I am checking whether I have to push that in the stack or not. So let us see. Yes, the stack is empty, A. So I have to push 5. The element is 5 for the first time, and I have pushed that into the stack. Assume that this is a stack. Okay, this is a stack of numbers. Fine. Now the element is 3 after traversing the array. So we will check the stack is not empty, but the element is less than the top element because the top element is 5. So 3 is obviously less than the top element. So 3 is again pushed into the stack. Okay. Now 2, similarly 2 is also pushed into the stack because it is also less than the top element. Now comes 10. So what will happen? 10 is greater than the top element. So it will come to the second step. If element is greater than the top element, yes it is, then pop the elements of the stack till the element is less than or equal to the top element. So we have to clear the stack until unless we again makes to this condition, makes to this snapshot or what you want to say. We have to go to this point after iterating the stack up to if the element is less, then we will stop. If the element is greater, then we will be popping the elements from the stack. Okay, so here in this case 2 will be popped. So here's the, oh, I'm sorry. So the output I am going to write is, here's the output. So 2 have the next greater number as 10 and 2 is popped. Now the top is pointing to 3. So 3 again is less than 10. So 3 is again popped from here and should be written here, and the element is marked here with the greater element. 5 is also popped because 5 is also less than 10. Now the stack is empty. So if the stack is empty, I'll just push the element into the stack, right? Now I come back to the element number 6. Okay, element 6. So 6 is less than 10. Just push it on the stack. 8. So 8 is greater than 6. So 6 is popped here. 6 is popped here. And its next greatest element is 8. Now 8 is less than 10. So in that case, I will be pushing 8 onto the stack. Now, this situation is something similar to this point, 1b. Okay. Now comes 1. 1 is smaller than the top element, so just push on the stack. Now comes 4. So element is 4, but it is greater than the top element. So 1 is popped and written at the bottom. Now 4 is less than 8, so I will be just pushing the 4 in the stack. Okay. Now comes 12. Okay. So 12 is greater than 4. 4 is popped. For 4 we have 12. Again 8 is popped. For 8 again we have the greater element as 12. And obviously 10 is also popped. So for 10 also we have the number as 12. 10 is clear and 12 is pushed. Now 7 is the next element to be queried. 7 is again less than 12 and 4 is again less than top, and 4 is again less than top, that is 7. So we have, after the complete traversal of this array, we are left with 3 elements in the stack. So the output will be something like the 4 has nothing. You can clear the stack at the end. 7 also has nothing, and 12 also has nothing. Okay, so this will be the expected output which we are going to write in code. So let's start the code without wasting any time. I hope you got that. uh, I'm not removing this algorithm part so that just we can at least refer to it if we are doing something wrong. So first of all, I'm going to make a stack, and that stack will be a generic stack. Struct stack, and by generic stack I have to write t or anything. T is like type or template. uh, Now in stack we have an items array, so t that will be an empty, and we have two very important functions. One is push. Okay, for push I have to pass an item, and that will, I'm keeping this function as mutating because I have to modify this. Items dot append, and that is item. Okay, and mutating func pop, that will actually return the last element, the top element. Okay, or the topmost element, not the topmost element. That is items dot remove last. Okay, so we don't need to write the return here in the function, because in Swift 5, if there is a single line in the function, so then we don't require any return statement. If we have more than one line, then we have to write return. Cool enough. Now I'm making a top property that is actually referring to the top of the stack, and that will just return an optional value because I'm using the last here, the last property here, and it is actually returning an optional. So top is optional, and we can also make an is empty property, or we can just check from items. but let's make a property bool, and it will just return a boolean by checking whether the items are empty or not. That's it. So I think from the stack point of view we are done. Now let's jump to the basic algorithm. For before that, we have to make another structure or maybe another class or any data source. Like I will name this as answer, because the output needs to be be like this, where there is a number and it's the corresponding greatest number. So var number, which is an integer, and var greatest, we can also make that generic. Over the time being, I'm making that as int. Okay, so greatest number, next greatest number, it should be next greatest number. Okay, fine. Sorry. So now let's start with the proceedings. So first I'm going to make a stack, and that stack will be of integer, since we will be we will be using an integer array. And I also will be making an answers array, and that will contain the output, this output basically. Okay, now let's start with the logic. So we have to follow these two steps, and we have to traverse the array. So for element in array. Okay, fine. Now in the element, for the first step we have to check whether the stack is empty. So a very simple step: if stack is empty, okay, just push the element onto the stack. Simple. Okay, or we can also check if the stack is empty, or what it says, if the stack is empty or the element is less than the top element. So we have to check whether we are getting the top element or not. So it can be like this. Let's do like this: if stack is empty, we just push it and just continue, so that the for loop gets continued. Now let's check out the top element. So if let top equal to stack dot top, and if top is actually not top, if element is less than equals to top, okay, then we have to push again. So what this says, if element is less than or equal to the top element, then again we have to push onto the stack. Okay. Fine. Okay, stack dot push, and the element is pushed. It's fine, and we can continue the for loop. Now comes the third part. So the third part is if the element is actually greater than the top. So either we can do this way, we can just have a top for the single time. We should have like this, sorry, we can make like this: if element is greater than top, we just continue the loop, else we don't need to continue. Actually we can use, it will go in the else block, but obviously continue will also work because we don't have any other statements here executing. But I'll keep that as if else block. So this else block is denoting the second point. So if element is greater than the top element, so here I will only come if the element is greater than the top element. Okay, fine. Then we have to make another loop just to iterate the stack, and along with the iteration I have to do the popping part as well. So while stack is empty, that should be not, while stack is not empty, then what we have to do, we have to check two things. If the top element is greater than the element, basically in that case where we are having uh, we are having for example say 8, and 1 comes at the top, so 1 is actually less than the topmost element, so that is what I'm talking about. So if top is greater than the element, then we will simply push the element onto the stack. That's fine, and we'll just break that. Okay, and if it is not this, then we will actually append into the answers our array, because we know that the item at the top is greater than the item, sorry, the item at the element is actually the greater than the topmost element of the stack. Answer dot init, and the number will be the, I think number will be stack dot topmost. So I'm using pop here. So what pop will do, pop will remove the stack element, the topmost element, and also return that element. Okay, and the next greatest number, which is actually the element. I think that is it. Element, let me check. Yes. Okay, one more thing. Finally, if the stack is empty, for example, and we made it to this line, we can only make this if the top element is greater than this element, then only we can make to this line, and that line should be outside the while loop, right? The final statement basically. So if the stack is empty, then we have to push the element in onto the stack. That is the case where all the stacks 532 was popped out, and we were only we had only the element number 10. So 10 should be inserted into the stack, pushed into the stack. So stack dot push, and that should be the element. So I think that is done. We have successfully implemented algo. So let's write the output. So output will be something like for answer in answers, and I'm just going to print the numbers by using the interpolation. Answer dot uh, what is that, number, answer dot number, answer dot number, and the greatest element will be for this number will be answer dot gen greatest, what, again it's answer, the next greatest number. Okay, so let us see everything is okay. Algorithm has two steps, 1 and 2, and I think one step is this is actually denoting the first step, and this is completely denoting the second step of the algorithm. So this is the second step of algo, and this is actually the first step. Till this line, it's the first step. Okay, let's run this to see whether we, okay, so we have 2 10 3 10 5 10 6 8 10 8 1 4 8 4 4 12. So let us see. 2 10 3 10 5 10 is fine, 6 8 is fine, we have 10 8. Okay, we have 10 8, we have 1 4. Okay, there is some problem that this 10 8 is coming. I have missed that thing. No, I haven't. 10 6 8. Okay, 10, that is wrong actually. That should not be there. 10 8 shouldn't be there, because 10 is not 10 is less than 8. So let me check what is the problem in that case. just a second. Element in array. If array stack is empty, stack dot push, that is fine. Now I come to the top. If element is less than equal to stack dot push, that is again fine. I'm coming to while stack top is greater than. If top is, why I'm checking this actually should. Okay, yeah, we have to check that thing as well. Okay, we have top here. Uh, if okay, the problem I guess is when I'm pushing onto the stack. In this case, uh, just a second. Top element is greater than element stack dot push break answers. If stack is empty, stack dot push is element. Something is, I guess, not right with the original element. Stack is stack push continue if let top. If element is less than equal to top, stack dot push else while. Okay, while stack is empty, so this top element. Okay, okay. I got the problem here. The problem is, I guess I'm not updating the top here. The top is actually the value which is coming from the optional binding case. So I don't have to write this. I have to again because since you know stack is modified here. Stack is modifying here. I'm popping the stack, so I have to write the pop value as well here. So if let top equal to stack dot top, because top is updated every time, so this won't work in that case. So I'll write this thing here, and I think it will fix the bug. So let's go. Oh, sorry, I haven't checked. I have to check as well if top is greater than the element, right? I think it will work well now. Sorry. Okay, so 2 10, 3 10, 5 10, 6 has 8, 1 has 4, 4 is 12, 8 is 12, and 10 is 12. So these three are missing. So we can either first no, we can either first add on answers, or we can just pop the stack, or we can just show on that. So let me just add on the answers itself. So while stack, if there is something in the stack, so I'll write that answers dot append, and let us make that optional, or either I can just display that thing of while I'll show you. Print the numbers are actually stack dot pop with a no case. Okay, stack is empty at the end, so this is our output. So we can now actually verify. So 2 10, 3 10, 5 10, 6 8, 1 4, 4 12, 8 12, 10 12, 4 no, 7 no, and 12 no. So either we can also have these displaying in the answers itself. Then I have to make the greatest number as an optional. Then I can just add those in the answers as well. So answers dot append answer, just a second, answer unit, and I have the stack dot pop, and I don't require this, so I'm just going to make this constructor, and that should be above the answers. And obviously now this will return a optional thing. So if let greatest number which there will be a greatest number. Either I can just force cast it, because I'm very sure that in this case it will be having a value, but still I will be just using the optional chaining answer dot number. So what I will do is replace it with the greatest number, and that's it. So your complete data source is made. Initial sorry, greatest number again. Fine. Now let us run this app. So we don't have any value of this, so it is not printing. So either we can do like print answer dot number, basically the same thing, and I'll just print a no statement. So that will work. Now you can compare the output. 2, 10, 3, 10, 5, 10, 6, 8, 1, 4, 4, 12, 8, 12, 10, 12, and 4 no, 7 no, and 12 no. So this is the complete implementation of the next greater element of the element in an array. Okay, I think we can also improve this code a bit, because this is the first time writing this code. Probably we can make some uh, more fancy changes so that it just improves the runtime. But I guess the complexity is on square, because we have a for loop here, and we certainly have a while loop within a for loop. So this is the complete implementation. Thank you so much for watching this video. If you do have any questions, just do let me know in comments, and also let me know for the improvements. Thank you so much.